for this lesson, we're going to be diving into more families of graphs, or if you will, just more parent functions. So we've learned 4 parent functions in the first unit, and so now we're going to add about 6 more to your list here. Keep in mind that we'll be discussing transformations again, and these 6 parent functions have similar transformations to those that you've learned before. So let's just take a look at a few of your new ones. So we're going to start with something that actually seems even more simple than before, and that's the constant function. Now, a constant function does form a line, keep in mind, but it's not the same as the linear function. It is always a horizontal line whenever we have a constant function. Now, if you think about vertical lines can't be functions because of the repeated x value on a vertical line. So the constant function is always a horizontal line, and it's always going to equal to whatever value all of the y values equal to. And so wherever that horizontal line crosses the y-axis, that is the value for our constant function. And so that's one of our new functions. Now, its shifting or its transformations are going to be special or treated differently because of the fact that it's just a constant number and there is no x value associated in the equation. So just keep that in mind as we learn that a little bit. Okay, now the other thing that you can see here is that the linear function is technically called the identity function. Now, that's not new for us. It still creates a line, and it still creates a shifting whenever we add to that identity function. So we tend to more generically call it a linear function. So as we go down, you can see we've got special types of polynomial functions, higher degree exponent functions, if you will. So we've got x squared and x cubed. So we've already talked about quadratics and cubics at this point. So we'll move on down. Again, we can see the square root function. We've worked on that one before. Now this other one, the rational function, is a little bit new to us, sometimes called the reciprocal function, because you can see that the reciprocal of x would be 1 over x, and so we have the reciprocal function. Now keep in mind that if we were to say x plus 2 on the bottom, that's no longer a reciprocal of x, it's now what we would call a rational function, but the shape of the graph is still similar to what you see in the reciprocal function. Now, we may have mentioned this in class at this point. The reciprocal function has 2 asymptotes, which are barriers that the graph will not touch, and so you can see that curvature at the x and y axis. So asymptote is something that we'll discuss further in later lessons. Piecewise functions. Piecewise functions are exactly what they sound like. They're pieces of different graphs. The first major piecewise function that you would be familiar with is the absolute value function. So the absolute value function is actually the piece of a positive linear function and the piece of a negative linear function. And so it's 2 parts put together, and so it's called a piecewise function. So absolute value functions always make a V-shaped graph, whether they're upside down V or they're a regular looking V. Now the other piecewise function is a greatest integer function. Now this is typically a hard concept to grasp, but the easiest thing to think of is sometimes they're called step functions. And I think it's clear why it can be called a step function, because it looks like a set of staircases. Now, the one thing that's important about this for it to pass the vertical line test is that you have open circles and closed circles on the vertical line, so that there are no repeating x values, so that it keeps its function definition. And we'll talk about greatest integer function in more detail in class. As we move down, we see the exponential function and the logarithmic function. Now these are technically inverses of each other, and we'll talk about what an inverse is more detail later on as we learn about more functions. But the first thing that you can basically see is that the exponential function and the log function look like opposites of each other, and that's basically what the inverse is implying. And so we will be working with these 2 functions together in a unit because they go hand in hand with each other. And so you can see you have roughly 6 new functions to add to your parent functions. The transformations of these functions will be very similar to what you've seen in the past. And we'll just need to get to understand the basic principles of them. Our objective in Algebra 2 will be to cover all these in detail. Now, if at any point during these videos you come across a question, it's very important that you write it down so that we can discuss it in class.